In this video, I will discuss security in web application development. I find the moment that I deploy a web application on the internet to be extremely terrifying. The internet is an incredibly hostile place. It takes almost no time between connecting your computer to the internet and it getting attacked. Even if you run a minor web server that you think nobody cares about, you'll still find your web access logs filled with constant probes for many different security vulnerabilities. If you have an active SSH server, then you'll constantly get login attempts. If you have a mail server that allows open mail relaying, it won't take long for it to be discovered and exploited. And that's if nobody cares about your server. If you have something valuable, then you're also going to have to defend against determined adversaries. The problem with security is that it's very one-sided. There are so many attacks from so many places and so many things that you can do wrong. But it only takes one mistake to cause embarrassment at best, or serious damage at worst. It's you alone, or perhaps a small group of people, up against an entire world of experts and determined attackers. Even if you're very careful, if you work for long enough with computers, then you'll eventually make a mistake. Unfortunately, almost every system is vulnerable, and the more systems you have, the more vulnerabilities you have. Unless you never connect your computer to the internet, it is difficult or impossible to guarantee security. I have to confess that I've made more security mistakes in my career than I should have. And I'm probably still making them, so perhaps I'm not the best person to talk to about security. However, I do keep trying to improve, and I do try to think through the security consequences of everything I do. Fortunately, there are common patterns in security problems. Not every security issue is completely unique. In fact, some mistakes are extremely common. They keep occurring again and again and again. They keep happening because sometimes the simplest and most easy way to do something is actually the most dangerous. For example, I've spoken previously about how in JDBC, the easiest way to check a username and password is just to join together strings. Using prepared statements seems harder and perhaps even pointless at first. But if you join together strings, then the user can write SQL inside their password and therefore bypass all of the security code you've written. Prepared statements are less obvious, but they're far more secure. The Open Web Application Security Project, or OWASP, is a non-profit organisation devoted to improving security of software. If you'd like to learn more about security, I recommend visiting their website. They've got manuals, guidelines, cheat sheets, as well as tools for learning about security and testing security. If there's only one thing you do, however, my recommendation is that you should read and understand the OWASP Top 10. This is probably the best known and most common guide for web application developers to get started with improving their application security. It lists 10 of the most common and most severe security issues faced by websites. However, right now, I'd like to briefly discuss some of the OWASP secure coding principles. These are some general ideas about programming that can help you ensure that your system is more likely to be secure. First of all, you should try to eliminate features. You can't attack a system that doesn't exist. Next, you should ensure that your code is secure by default. If you've got a setting, then make sure that the default value is the more secure option, so that it is easy to be secure and it takes work to make the system less secure. You should give each system and each server as few privileges as possible. Your web server shouldn't be running with full administrator access if the only thing it needs to do is read files in a single directory. You should have multiple layers of security. Don't just trust the firewall. Every system should be as secure as possible, so that if somebody gets through one of the outer systems, you've still got more layers of protective security. When things go wrong, the failure condition should be more secure. So for example, you might have code that checks a username and password. If the user is valid, it returns true. If the user is invalid, it returns false. But what happens if the code throws an exception? When you use the login method, you should design your code so that an exception is handled like an invalid password. You shouldn't trust external systems, even your bank. They may not be as secure as you think they are, and even if they are secure, you can't always be 100% sure that your code is connecting to what you think you're connecting to. Somebody else might be intercepting the request. You can still use external services, but just don't make it that if somebody can hack into the external system, then they can use that system to do damage to your own systems. Try to separate duties. Don't give everybody administrator access. Don't rely on secrecy to secure your system, and don't assume that nobody would want to hack into your system. Every computer on the internet is attacked constantly. Keep things simple. The more complex your system, the more places for error. But of course, you don't want to have things so simple that there's no security protection either. You want to find a balance, but when in doubt, aim for simplicity. And when you do discover problems, don't just treat the symptoms. Understand why it went wrong. Fix the root cause, rather than just putting together a quick patch up to avoid the particular security report that just happened. If there's just one point that I'm trying to make, it is that as developers, we need to be constantly aware of security. Think about every feature from every angle. Ask yourself, how could this feature be abused by somebody with malicious intent? Sometimes it can be difficult to imagine how code could be misused. Understanding the different kinds of vulnerabilities and methods for attacking systems can help you to understand the potential consequences of the code you write. So for this reason, as a software professional, you should pay attention to security news and major vulnerabilities. Whenever you learn of a new attack or technique, you should revisit that question. How could my code be abused by somebody with malicious intent?